Hello everyone, I am Aditya Sauri. Today our topic is binary trees in data structures. We already know about the topic about data structures, linked list, stacks. So you learned all those stuff in previous videos. Now let us discuss about binary trees. Before going to the topic, let us see the definition of data structures. Data structure is a way to store and organize data so that it can be used efficiently. Data structures such as array, pointer, structure, linked list, stack, queue, graph, searching techniques, sorting techniques, programs, etc. So with the help of these data structures, we can write the programs how to deal with data. So we already know when we are working with any software applications, the main theme is to store the data or to supply the data from one location to another location. So we all are working with data, that means information only. So we have to store that particular information in memory devices. So we have lot of memory devices, but how can we store? So many techniques are there to store or to working with data. So these things we can learn in data structures. A linear data structure, okay, actually we have two types of data structures. One is linear data structures and another one is nonlinear data structures. A linear data structure have data elements arranged in sequential manner, and each member element is connected to its previous and next element. This connection helps to traverse a linear data structure in a single level and in single run. Examples of linear data structures are list, queue, stack, array, etc. As per our syllabus, first two units belongs to linear data structure concepts, and this stuff also completed in previous videos. So actually linear data structure means here the data will be stored one after another element. So we already know about array and stacks. So in these things, in these concepts, you learned how to store the data, how to retrieve the data, how to delete the data, how to add the data. So these things you already learned. So these things comes under linear data structure. But when going our concept, our topic is binary tree. So binary tree concept comes under nonlinear data structures. Nonlinear data structure. Data structures where data elements are not arranged sequentially or linear are called nonlinear data structure. It is a nonlinear data structure. Single level is not involved. It utilizes computer memory efficiently in comparison to a linear data structures. Its examples are trees and graphs. So the concepts of trees and graphs comes under nonlinear data structures. So when we compare it to linear data structures, all the data will be stored in a closed relation. So when we take the concept of arrays, all the data elements will be stored in contiguous format. And when we take the stacks concept, the data will be not stored in contiguous format, but all the data elements will be in closed relation. So each node can be interlinked each other. So all those things are closed only. So these things comes under linear data structures. But when we discussed about nonlinear data structures, the data elements will not be in closed relation. Here we can see the diagram representation of a tree. So here A, B, C, D, E, F, so many nodes are there. For example, if we take A, B, C, these three nodes, we can observe that here B and C are not in closed relation. So these kind of representation comes under nonlinear data structure. When we take arrays and stacks and linked list, all the data elements will be in closed structure. There is a something, one connection will be there for each and every element. So these comes under linear data structure. When we are discussing about nonlinear data structure, there is no closed relation from one node to another. In this example, B and C don't have closed relation, FG don't have closed relation, J, F, I, J, H, I. So many nodes are there. These nodes don't have any closed relation, and this concept comes under nonlinear data structure. So I think now you understand the difference between linear and nonlinear data structures. Okay, now let us discuss about basic terminology of binary tree. So we have so many terminologies like edges, root, leaf, node, parent, child, siblings, etc. So we can discuss each and every terminology. So first one, node. So element of a tree is known as node. So in binary tree, when we created a node, so in this example you can see A, B, D, E, H. So these are called as node in trees. So these are called as nodes. So in this example, A, B, C, F, D, E, D, so are called as nodes. So in these nodes only the data will be stored. Next one is root node. Starting node of a tree is known as root node, and a tree will have only one node. So when we see in this example, so we already discussed the definition, starting node of a tree. So in this example, what is the starting node? In this example we have so many nodes, and what is the starting? A. So here A will be called as root node, that means starting node. After that, edges. Connection between two nodes is known as edge. If we have n nodes, then we have n minus 1 edges. So these round circles are called as nodes, and when we take A, B nodes, here one line is there, and this line is called as edge, and with the help of edge we can interlink nodes. So the formula of edge is n minus 1. Here n is number of nodes. So in this example we have 1, 2, 3, 4, 5, 6, 10 nodes are there. So if we have 10 nodes, we have 10 minus 1 edges, that means 9 edges. So n minus 1. So we can count here 1, 2, 5, 6, 7, 8, 9. So in this way we can calculate the edges also. Next one, parent nodes. Node with branches from top to bottom is called parent node. So in this example we have so many nodes, and some nodes are parent nodes and some nodes are child nodes. So we are discussing about only parent nodes. So here A is a root node because it is the starting node. That's why we call it as root node. And it is also called as parent node because A is the starting node, and for this node we have child nodes like B, C. So that's why A is also called as a parent node. And here B, C are also a parent nodes because for B two child nodes are there. that is D and E. For C, two child nodes are there, that is F and G. So here B, C are parent nodes, and D, E also parent nodes, because D has two child nodes and E has one child node. Next, child. Node with edges from bottom to top is called child. So here HI is child nodes of D, and DE is child nodes of B, and BC is child nodes of A. So in this way we can see the child nodes also. Next one, siblings. Child nodes of same parent node is called as siblings. So when we discuss about this example, A add two child nodes, that is B and C, because B, C nodes are belongs to A parent node, and these two nodes are called as siblings. And FG is a sibling because these two nodes are belongs to C parent node. But D and F are not siblings because D parent is B, F parent is C. And here D and E are siblings because these two nodes are belongs to B parent. Next, leaf. Node without child node is called leaf. So if a node don't have any child, it comes under leaf nodes. So in this example, H, I, J, F, G are comes under leaf nodes because they don't have any another child nodes. So another concept is degree. Number of child nodes represents degree of node. The maximum degree among all nodes is known as degree of tree. Okay, when we take this example, here degree of A means 2 because for A node we have two children, so that's why degree of A means 2. If we take degree of B 2, degree of C 2, so this concept is called degree of node. Then what is degree of tree? Okay, if we have more nodes for a particular parent node, that means maximum number of nodes for a particular node is called degree of tree. So in this example we have maximum number is 2 only. For degree of A 2, degree of B 2, degree of C 2, and degree of D also 2. So these are called as also degree of tree. For example, if we have 3 nodes for D, that means degree of D is 3. If then the degree of tree is D. Okay, next thing is internal nodes. Nodes with child nodes is called internal nodes, or all nodes other than leaf nodes is known as internal nodes. So when we take this example, A as children, C as children, B as children, D as children, E as children. So these are called as internal nodes because A has 2 children, B has 2 children, D has 2 children, E also have 2 children. So these nodes are called as internal nodes, and remaining nodes are not called as internal nodes. Next, level. So in tree, level starts from 0. That means here we have 4 levels. So in this example you can see level 0, level 1, level 2 and level 3. Actually we have 4 levels, but the level value will be start from 0 only. That's why we have 0, 1, 2, 3, 4 levels. For every step hierarchy level will be increased by 1, and every step hierarchy level is a level. So here A is one level, B, C is another level, D, E, F, G has another level, H, I, J is another level. So here we have 4 levels in this example. Next one is height. Longest path from leaf node to that node is called height. Okay, in this example, if we take A, so if we like to find out the height of A, so we have 2 nodes for A. One is B side and another is C side. But we have to take the highest side only. So when we take B side nodes, so A to B, B to D, D to H. That means height of A is 4. That is A to B1, B to D, D to H. But this C side will not work, because when compare it to B side and C side, B side length is high. That means height is high. So that's why we have to take B side only. If C side is more than B side, then we can count the C side. Next one is depth. Longest path from root node to the node is called depth. So when we take highest, we calculate that from root node to leaf node, but in depth we have to take the node to root node. That means upward direction. In height we calculate from top to bottom. Here we have to calculate from bottom to top. Okay, if we take here the D node in this example, so the depth of D is 2. That means we have to go upward direction. That means D to B, B to A. So longer we have to check the longest path only, same as highest also. So we have to check for longest path, not the shortest path. So if we check depth of F, it is also 2. That means F to C, C to A. So if I take H, H to D, D to B, B to A, that means depth of H is 4. Okay, next one is path. The sequence of nodes from source to destination. That is, root to leaf is called as path. Now if I like to find the path of A to I, so where is I node? Here. So how it is traveled? So from A to B, B to D, D to I. So in this way we can find out the path of a node. If I like to find out the path of G, so A to C, C to G. If I like to find out the path of J, A to B, B to E, E to J. So in this way we can find out the path. Now last one, subtree. Node with child node called subtree. So here A is the parent node. For this we have 2 childs, B and C. So here B and C have children. So here it becomes a subtree. For B D and E are nodes. For C, F and G have nodes. So these two things are also called as subtree, and D is also called as subtree and E is also called as subtree. Now let us, we discussed the definition with the diagram. Now let us implement some examples with this help of diagram only. So now let us see the examples. So node, we already discussed what is node, and when compared to this example, every element is a node. That means here A, B, C, D, E, F, G, H, I, J. So these are all called as nodes. Then what is root node? So this thing also we already discussed. So the topmost node is called as root node. That means A only. So edges. So we already discussed this thing also. So to find out the edge, we have to do some calculation. That is total number of nodes minus 1. Here we have 10 nodes. Minus 1 means total 9 edges are there for us. So A to B, B to D, D to H, like that. Here we can count also. And parent node. So this thing also we already discussed. Node with branches from top to bottom. So here A is a parent node because A has 2 nodes, and B also is a parent node. D, E, C. So these are called as parent nodes. And child nodes. So the nodes which is rooted from a parent node are called child nodes. So here B, C are child nodes, and for B we have D and E child nodes, and from C F and G are child nodes, and for D H, I are child nodes, and for E J is child node. Now siblings. So siblings means child node of same parent node. So for A, B and C all are the children nodes. So these two are siblings. For C, F and G are children nodes. So these two are siblings. So BC is sibling, FG is sibling, D, E is sibling, H, I is sibling, and for J there is no another child node, so it does not belongs to sibling. And next, leaf. So node without child node is called leaf. So the node which does not contain any another child node is comes under leaf. So here H, I, J, F, G are leaf nodes. And degree. So we already discussed what is degree. Now I would like to find out the degree of A. So what is degree? Number of child nodes represent degree of node. So degree of node means, so for A node we have 2 children. That means degree of A is 2. If we like to find out the degree of E, so degree of E is 1 because E contains only one child node. So if I like to find out degree of C, so for C we have 2. So in this way we can find out the degree. Next, internal nodes. Nodes with child nodes is called internal nodes. So the node which contains children is called as internal node. So in this example, A has child, B, C, D, E have children. So these nodes comes under internal nodes. Next, level. So we already discussed about level, and in diagram also you can see level 0, level 1, level 2, level 5. And height. So height means longest path from leaf node to the node is called height. So if I like to find out the height of A, so we already discussed we have to see the longest path only. So we already discussed B side is the longest path and C side is the shortest, and we have to see only the longest path. So that means height of A is A to B, B to D, D to H, that means 4. Height of B, so B to D, D to H. Of course we can see B to E, E to J also, as per our wish we can see. So height of B is 3. Now depth. So longest path from root node to the node is called depth. It is same as height, just reverse. So the sequence of nodes from source to destination, that is root to leaf. Okay, now I would like to find out the path from A to E, that means A to B, B to E. So in this way we can find out the path. Now I would like to find out the path between B to J. So how it will be traveled? So from B to E, E to J. So in this way we can find out the path of a particular nodes. Now subtree. So here B is a subtree, D is a subtree, and C is also a subtree, because for a tree there are so many subtrees. So here A is a tree and A containing so many nodes, and we already know B and C are the children of A. For B there are another children, for D there are another children. For compare it to this thing, okay, from B to J, okay, this thing is a subtree and D is a subtree. So in this way we can find out the subtrees.